Now I can get the pen. Yes, here you can see now. We have here you see 1, 2, 3, 4, 5, 6, 6 piles are there for this pier. So by and large, you can see for P2, P3, around 7 piers are there, and obviously 2 abutments, what we call retaining walls. So this abutment, you know, that is load is more here. We can see maximum number of pile group having maximum number of piles here, 1, 2, 3, 4. See, this configuration of pile is 3 into 4. So 3, 4 jars is 12. So now the thing is actually, this is about the bridge, and this is pile cap. Probably the diameter of the pile you can see here, and you see here about 23-meter length pile they have suggested. I'm not very sure about all these things, but I can tell you what's happening here. The thing is here, you see, many times you may ask a question, sir, what about pile cap depth? Generally, they adapt 2D. 2D means here diameter of the pile is 0.75. 2 into 0.75 is 1.5 meter. I can write in, I say, so 1500, here you can see now. So anyhow, these are the particulars. You can see now, you will have a feel of bridge here. So anyhow, I want to give an information about subsoil profile. I was there actually for this construction of bridge. This soil report is given by me actually. So that's why I am showing this story. I'm not showing something is downloaded from YouTube or someone's data. I'm just showing my experience actually. Okay. So I have done the investigation. Actually, myself is there actively involved in the subsoil investigation in 2014. Maybe it is my golden days in my life. So 1 meter filled up soil. And at 6 meter, you see many times we have a clay soil. So after 6 meter, it's very interesting to see. It's most of the time Vijayawada is alluvial soil. So it's not nothing to surprise. We have a sandy soil, right from 6 to 14 meter, poorly graded sand. So now you see the profile is also something tricky, SPT values. So many times we believe SPT. SPT is good, I think. There is no issue. We don't have any soft clay. Sometimes we use it to get N0. I told you Kolleru, N0, and even N2, 3, 4 like that. But here the ground is medium stiff. There is no issue. Even sand is also, I cannot say it is dense sand, but I can tell you it is something medium dense sand. Okay, now the thing is good. After 14, we come across a red gravel. This is a typical terrain and very interesting. We come across a soft disintegrated rock right from 15 to 17. And because you see, we know that I cannot say now I'm going investigation for 5 meter or 10 meter. So here we are doing investigation for the bridge. We are doing investigation for the sake of bridge. There is no compromise. And the thing is, while you may ask, sir, what is the depth of boring? Depth of boring. Our interest is we want to do investigation beyond rock also. Even we are ready to see hard rock also, but we are not sure we will get hard rock. Our interest is we want to do subsoil investigation. Even if rock come, we want to continue the investigation. And many times we decided to go for minimum 30-meter investigation. We decided actually. We decided to go for minimum 30 meters because it's a railway project. Here there is no bargaining. It's not question of money. There is no question of negligence. So we want to do investigation up to 30 meters. So obviously, you see, if it is an apartment building, we do up to 10 meter. We say that sandy soil is there. Everything looks good. Go for pile foundation up to 5 or 6 meter, and provide 2 bulbs under him. Then your pile is standing on hard soil, like what I say, sand. So everything looks good. Okay. But here there is no compromise, because it's whose structure we are going to construct here. So railway bridge, that there are a lot of dynamic load is coming from the superstructure. So there is no compromise, because that people working in Indian Railways are all are qualified in Indian engineering service. For your kind information, I'm telling you, if the many engineers they are working in Indian Railways, it's maybe South Central Railway or South Southern Railway, they are all qualified in Indian engineering service. They know actually they are the real engineers. We have to appreciate their efforts. So they won't compromise. I told them, sir, can we stop the investigation at 15 meter, or because we come across rock? Then there is one question from the engineer. No, sir, don't stop, because we don't know what is there after 17. So it was happened actually. After 17 again sand is there, because nobody can define the earth. Nobody don't, even you see, even God also don't know what is inside the ground. So we need to investigate, and we have to do boring. From that only we have to know. So there is no thumb rule. Nobody is expert in what I say, seeing the soil. You may be expert. Somebody say that this is a poorly graded sand. Its phi is about 32 degrees. Okay, it is our engineering judgment. But what is inside the ground? We have to investigate it. So make the borehole up to 30 meters. So I'm teaching each and every aspect. Don't mistake it. It is a interesting discussion. So now what happened after 20 meter? Again, SDR came. Soft disintegrated rock. Rock fragments are there. But the thing is, now we are not ready to stop the investigation. The reason is very simple. I can tell you. The reason is very simple, because we don't know. We are not sure if again sand will come. What we will do? Hope you understood my, I think what I'm trying to say. Hope you got it.
Yes, sir.
So then we are now, you see, nobody is saying stop the investigation at 22 meters. Now, because you see, we are working and we are understanding. What I say, nowadays people is calling interactive design. The experts are saying this kind of design is called interactive design. Based on work, we will understand. After, see, I'm not defining now, go for investigation 10 meter. Go for investigation 12 meter. I'm saying this formula is there in ASC, this formula is there in Japanese code, this formula is there in German code, this formula is there in European code. No, my ground is saying to me now. So based on this is what I call interactive design. Nowadays people calling performance-based design. So now you see, then up to 30 meter we have gone there. Now we realized that soft disintegrated rock. Then immediately we have taken a decision now altogether. So now you can go. Let me, I think. Now you can comfortably go for pile foundation up to 23 meter. Up to 23 meters. That's the story, the way the drawing is finalized actually. So somebody can say, so what is the use of geotechnical engineering? Here you can see here the level is kept by the engineer here. So based on soil investigation, they came to a conclusion, better to go for 25 meters. 25. The reason you see, in practice, the code is also saying, IRC 78, it is clearly mentioning, even the railway codes, they are trying to say that Indian railway standard, so try to terminate the pile. If it is a rock also, up to 2D. Up to 2D. Or better if you take 3D, we'll be happy. So now you can ask me, sir, you can ask me now. So 3 into, here the pile diameter is 0.75. Can anyone tell me the answer now? ఇది క్లాస్ నేను చెప్పినందుకండి మీరు నాకు అమౌంట్ ఇవ్వాలి, డబ్బులు ఇవ్వాలి. ఇది మనం కొన్ని చెప్పకూడదు. ఎందుకంటే ఇప్పుడున్న ప్రపంచం చాలా కమర్షియల్ వరల్డ్ అండి, చాలా కమర్షియల్. మీరు ఏదో అనుకున్నారు, మీరు రేపు మా దగ్గరకు వచ్చి ఏదైనా క్వశ్చన్ అడిగితే డబ్బులు కూడా అడుగుతామండి. మీరు స్టూడెంట్ కాబట్టి అన్ని ఫ్రీ మీకు. You are free like anything. You can ask anything actually. That is the advantage to student. So 3 into 0.75 is how much?
2.25.
2.25. Let me say 2.5. So hope you understand why the length of the pile is 25 meter now. Anybody ready to tell? ఎందుకు 25 meter పెట్టారు ఇప్పుడు మీరు చెప్తారా? The reason, after 20 meter we have a rock.
Continuous rock.
Yes, continuous rock. So they gone for around 4D, 5D. They socketed in rock. Pine cut off level poina 1 meter to 2 meter. So that's why they gone up to 25 meter. So try to understand the importance of soil, subsoil investigation. So subsoil investigation చేస్తే ఏం తెలిసింది? ఏ ఫౌండేషన్ వేయాలి ఫస్ట్ అండ్ ఫార్మోస్ట్. Second thing what I would like to tell you, it decides the termination of pile also. చాలా మంది అంటారు పైల్ వేయడానికే కాకుండా పైల్ టెర్మినేట్ చేయొచ్చు. We can terminate the pile. Hope you understood. So the interest of the railway engineers, if it is a soft rock, they will go 3 to 60 socketed in rock. If it is hard rock, they will go 2D like that, or if 1D. So their intention is they want to terminate pile in rock. So what your friend is saying is correct. Continuity. So now I will show you one by one how people constructing large diameter piles. At that time it is very excitement for us. 1 meter diameter pile. If you are observing at that time, you will be excited. Now people are 1.2 at Ben Circle. Now you see, maybe a day will come in Vijayawada, 2 meter diameter pile. Very soon what is happening in Mumbai, it may come. Now you see, this is a pile boring actually using this Who's hydraulic rig. Actually it's a very big rig, boring until it reaches the hard rock. So here you see step 4, terminating and iron case in lowering. This is the actually reinforcement case. And you can see here after boring with this drilling rig, they are trying to insert this reinforcement case. Here you see, I will explain. This is the way you see the crane is lifting the reinforcement case. And it's very surprising to see actually such a long pile around 25 meter with helical reinforcement. The good thing is there, it's fully helical reinforcement they have provided. It is helical reinforcement. Many times we are ignoring that actually in conventional buildings, apartments also, we are just providing rings, but it's good to provide helical rings. So helical reinforcement is good transverse reinforcement. So now you see a tremie is going on. I told you this is garata in Telugu. What you call in English funnel. So now the concrete will reach the last point. If you provide funnel system, what we call tremie method. So concrete, this is a self-compacting concrete, because you see the question is, you are an engineering student, you can ask a question, sir, how to compact 25 meter pile? It's very difficult to compact pile at 25 meter. At 2 meter I can compact, but at 25 meters is very difficult to compact. That's why you see the concrete is pouring like a liquid. It's like a self-compacting concrete. So one can see here you see actually the pilot test. During pilot test, what happened I will tell you actually. Here you see it is a initial test actually. Initial test before confirmation of the design, they use it to conduct. You see depth of the pile is 25, and the thing is during this pilot test, very interesting. They also actually got the value 230 tons about for a settlement of 4 mm like that. So now you can see this is the dial gauges they have kept. So now you see anyhow this is water is actually the stream is width is less, but there is a gush of water here. This is none other than Bodameru. So this is the bridge actually. what I say, existing bridge, existing track. Now they are proposing new track here. Hope you understood. So this is the rig in action now. Its job is to make a borehole. So you see, just to see, the height of this rig is the length of the pipe. Hope you understand what I am saying. So now you see the rig is in action. These are the liners actually. Usually we provide liners actually. They are mild steel liners. The thickness of the liner is 6 mm. Here you see welding in progress. They are joining the two liners. So this is a tank actually. What is a slurry tank? Actually, it's you see what happened inside this slurry tank. They use it to mix water and bentonite. So this is actually a motor used for mixing. So after mixing, I will show you. So this is the chisel of the drilling rod. Actually, there are so many methods. This is actually, it's almost a manual method. This is almost a manual method. There is no rig actually here. They are not using any rig here. They are just using chisel and barrel method. This is chisel they are using. And the thing is here, you see, this is barrel. Once you remove the barrel, the soil will come out, you see. This is chisel and barrel. I told you, this is chisel and barrel. Many times, you see, I found in Vijayawada, I have captured so many pictures. Many times, we engineers use chisel and barrel, but this is a slow process actually. Chisel and barrel method is a slow process, you see. This is the pump used for mud circulation. I will tell you, I will show you. This is, you see, this is chisel and barrel method by using tripod. So they are making the borehole by hitting the chisel. Now you can see this is a trimming. Anyhow, here you see, this is the reinforcement. This is the cover block actually. Maybe surprised to see this. This is 3 inch. The cover thickness is 3 inch, 75 mm for this pipe. And moreover, you can see this is a shining skin because they applied Protmax. Railway people, they use anti-corrosive agents for reinforcement. Whatever you are reading, they will use it. But you may not observe in the conventional buildings this kind of construction. And see, this is the V-poles. I taught you V-poles. This is the abutment for the existing bridge. I'm not confusing. This is the existing bridge. So we are thinking about a new bridge. This is parallel to this new bridge. Anyhow, see, this is piles after what I say cutoff. So you can see this liner actually. So liner, because they are also using liner here. So now after cutoff, you can see now here you see the cutoff in action. Now you see the reinforcement now. So this is the level now from this 25-meter pile is there. So now they will construct pile cap. What I said, okay. So now you can see everything. The beauty here is you might be seeing. Don't think that they are using something. These are all reinforcement bars with anti-corrosive. Okay, now don't worry about your reinforcement. And also you see each pile is connected to a top one, and they have side face reinforcement. So let us appreciate the designers and also the contractor. So now you see they are busy with sending concrete. Let me show you. This is now pile cap. Now you can see the reinforcement of the pier. So anyhow, so now you can see these are the. So this is actually we'll use it for making this helical reinforcement. This is what Protmax I told you. Protmax is an approved by Indian Railways anti-corrosive treatment coating for the reinforcement. Central Electrochemical Research Institute. So actually they suggested this. They have patent also. So anyhow, I think this is the rig actually. So this is what I can share you. But I will try to show some videos. From that, if anything missed actually, because a lot of information is mixed, I am trying to hear. So here you can see, this is the reinforcement case. I just went with my students actually. Many times I used to stay there, go there. Whenever I found time, we used to go there because nothing wrong. What's wrong with going there? And moreover, I was there actually. You see. So because you see, their length is limited, that's why they are doing welding. And I will show you actually some of the videos. You can understand actually. Here you see. This is it. Now, before actually the drilling started, you just imagine the length of the pipe. So this height of the rig is almost the length of the pipe. So this is our students actually. Now you can see. So this is very short, I think. Okay. We have very short videos at the time. You see, the small phones. Sorry, I think. Okay. Yes, now you can see this is chisel and barrel method of drilling. This is very easy method actually, and it's low cost method. It doesn't cost much because we are not using any rig here. We are just hitting the chisel. We are just hitting the chisel, and then ground will be broken. Now whatever the soil will enter into the barrel, we will now remove the barrel, and we use it to remove the soil. So just you see there it is winch is operating because you see people cannot hold this chisel. That's why your drilling rod is connected with wire rope. A wire rope is having controlling with this winch. So only people operating the winch only. So by operating the winch, they are hitting the ground. They are breaking the ground. From that they are trying to make the borehole. Just see now. Just see now. So how they are making the borehole? By using chisel and barrel method. Chisel and barrel method. So at top you can see this casing pipe. Below they introduce liner also. Because liner is required, because if sometimes if sandy soil is there, there is a chance for collapse of the borehole. That's why we are using liner. Hope you understood. This is chisel and barrel method. This is not hydraulic rig method. Let me show you. This is motor piling. It's very economical method actually. Here you can see. So how the boring is going on. So this is existing bridge. Existing bridge. Now it's a new bridge actually. Very near actually. It's very near. You can say from Muchalampadu you will go down actually. Where it is Allur Sitaram Raju statue is there. From there it is very near actually. That day is very interesting day. Those days actually going to Shivaji Cave, having some bread bhaji. So those days are very innocent days actually. Golden days I can call. So nothing is there. Just for learning we are going. Those days are very interesting days. Now we are arrested in engineering colleges now. So now I will show you flushing. Before that, I will show you drilling mud, bentonite slurry. Here you see, this is a slurry tank actually. Yes. Now actually during augering, they will send this bentonite slurry. So this is what I say, adjacent bentonite slurry tank. So now they are trying to send this slurry through drilling rod. Then what happened now? This mud is circulating. So now actually very surprising. Your class here, he has sent one interesting images recently. That is very interesting. That is not drilling mud circulation. That is reverse mud circulation. Very interesting video. We found, you can also find nowadays, if you go to YouTube, you are finding a lot of time. We are spending good amount of time in YouTube also. So go to YouTube and type drilling mud circulation. There are so many piling technologies available. I just showing only drilling mud circulation, and I'm showing just conventional method of boring, what I call chisel and barrel, and also using hydraulic rig. But nowadays in practice, there are maybe so many techniques. There may be so many techniques. This is the way piles are constructing actually. This is the way the piles are constructing, how the people are making pile. It is very interesting. So what technology they are using, driving technology, so installation technology, what they are using, how they can able to construct pile, bored cast in situ pile for 25-meter length, which is running almost rock, sand, clay. Just imagine, the diameter of the pile is 1 meter. So now I will show you flushing. After you see, after the borehole is stabilized, they are trying to do flushing. Flushing means they will send water. Then if any impurities are there in bore, it will be cleaned. It will be cleaned. So this is about what I say, general discussion on how people are constructing pile foundation. How people are constructing pile foundation. So this is very interesting discussion. So if you have any question or anything to ask, you can ask me. The pilot test we will discuss in the next day. But what I'm trying to show is simple. You can go to Google, just Google it. You go to YouTube. You may get more animated and well-organized videos. Drilling mud circulation. So it's a big thing actually. You can find the videos. You can go mud circulation. You will have a more idea, because in reality we can't see, but in animation we will see. See, after cutting, so it's again coming back to the tank, slurry tank. Now you see. So now the slurry mud is deposited here. Again they will use this water once again, because we are not supposed to waste the water. So again you see, water is entered. Now it's mixed with bentonite. Now mud pumping. So now you see. Now this is bentonite slurry. Now entering into the drilling ground. So it will come. Yes, sir. Yes, sir. Watch it. This is the end of the drilling bit. Okay. Now it mixes. It mixes with the. Now the problem is, now your slurry is mixed with soil also. So now what is this technique? Can anyone tell me? What is this technique? Drilling mud circulation. Enduku chestunarandi? Why they are doing like this? Because they want to stabilize the borehole. మనం తీస్తున్నప్పుడు బోర్హోల్ పడిపోతుంది కదా, కొలాప్స్ అయిపోతుంది కదండి. సో దే వాంట్ టు స్టెబిలైజ్ ది బోర్హోల్ డ్యూరింగ్ కన్స్ట్రక్షన్. అంటే హోల్ తీసేటప్పుడు, అగర్ చేసేటప్పుడు, అగర్ అంటే అర్థం అవుతుందని చెప్తున్నా, బోరింగ్ అనాలి. బోరింగ్ ఈజ్ ఆల్సో కాల్డ్ డ్రిల్లింగ్. సో జస్ట్ ఇమాజిన్ ద డ్రిల్లింగ్ టెక్నాలజీ. ఓకే, మీరు చూడండి, అంటే చాలా టెక్నిక్స్ ఉన్నాయి. ఇప్పుడు ఆయన చెప్పారు చూసారు, రివర్స్ సర్క్యులేషన్. అదేంటండి, రివర్స్ సర్క్యులేషన్లో డ్రిల్లింగ్ రాడ్లోంచి మట్టి బయటకు వస్తుంది. అసలు అది చాలా ఎక్సైటింగ్ ఉంది. అది టెక్నాలజీ అనేది చాలా ఎక్సైటింగ్ ఉంది. డ్రిల్లింగ్ రాడ్లోంచి మట్టి వెళ్ళడం కాదండి, డ్రిల్లింగ్ రాడ్లోంచి మక్క బయటకు వస్తుంది. మక్ అనొచ్చు, మక్ ఇస్ ఆల్సో రైట్ వర్డ్, మక్. సో ఇట్స్ వెరీ ఇంట్రెస్టింగ్. నవడేస్ లాట్ ఆఫ్ చేంజెస్ ఆర్ హ్యాపెన్. సో హోప్ యూ అండర్స్టూడ్ ది డ్రిల్లింగ్ టెక్నాలజీ. లాట్ ఆఫ్ చాలా మార్కెట్ ఉందండి డ్రిల్లింగ్ టెక్నాలజీకి. మీరు చూడండి, వరల్డ్ క్లాస్ కంపెనీస్, ఆటోమొబైల్ కంపెనీస్, వాళ్ళు ఏం చేస్తున్నారండి? వాట్ వరల్డ్ క్లాస్ కంపెనీస్ ఆర్ డూయింగ్ నౌ? దే ఆర్ మ్యానుఫ్యాక్చరింగ్ టన్నల్ బోరింగ్ మిషన్స్, అండ్ నౌ దే ఆర్ మ్యానుఫ్యాక్చరింగ్ hydraulic rigs, piling rigs. So just imagine, I'm not praising mechanical people. Above all, we are all engineers. We have to interact each other. అతను డెవలప్ చేసిన టెక్నాలజీని మనం ఇంప్లిమెంట్ చేస్తాం. We civil engineers will fulfill the dreams of others. అది మనం గొప్పతనం మాట. సివిల్ ఇంజనీర్ ఏం చేస్తాం అంటే, ఎంత వేయాలి, ఎంత కట్టాలి, ఇవన్నీ చూసుకుంటారు. సో వీఆర్ లైక్ బ్రహ్మ యాక్చువల్లీ. సో విత్ దిస్ ఐ థింక్ ఐఎమ్ కంప్లీటింగ్ మై లెక్చర్. Hope we will meet in tomorrow. So, if you found any disturbance, actually I want to show something to you.